Hi, everyone. I apologize that I'm gone today. I have caught what my girls have gotten, so I'm not feeling super great. But I wanted to make sure that we got these notes. I think we all kind of ended in a couple different places. And so I'm just going to review this first page and then move on to the second. And what you see on the screen, you should have in your notes. There are extra copies on the counter over kind of by the window where the handouts usually are if you need a copy. But this will hopefully kind of put all the pieces together of why the crust is moving. So last class, we did an experiment where you saw the red vial water was rising to the surface and the blue water stayed in the vial because it was too cold to rise. And so from that, we talked about convection and how warm material rises because it is less dense. The molecules are moving faster. They're spreading apart, which causes it to rise. And then when things are cooled, the molecules start to slow down. They get closer together and they sink. And this whole idea of this cycle is convection. So we had the definition of convection is the process of heat transfer in an unevenly heated fluid. It creates a cycle. And then we talked how a lava lamp, boiling water, and convection ovens are all examples of where this heat is cycling through because you have a heat source on the bottom, it's cooler on the top. Same with the boiling water, the burners on the bottom, the air is cooler, it creates this cycle. We can't necessarily see the cycle because it's clear water, but it is happening. And then same in a convection oven. A convection oven has a fan to cycle the air through, which creates a more even heat. And then we had this diagram showing how the cold is sinking, and we added notes that just to make sure you are remembering that the molecules are slowing down and getting closer together, which makes them more dense and they sink. And they're rising because they're less dense. And so making sure we're kind of really understanding how density impacts this, that's like a really key point in what allows convection to happen. And that goes back to our lab that we did with the density column where things layered out based on their densities, but they can only layer out if they are fluid. And when we say a fluid, that leads us to our requirements. A fluid is a liquid or a gas. And so it just has to be able to flow and it has to be unevenly heated. And that brings us to the back side of these notes. In the earth, the upper mantle is a very, very thick liquid. It is unevenly heated. And so it has the two requirements needed for convection to occur. And so again, up here it says convection is the process of less dense, hotter material floating and more dense, cooler material sinking. And then I apologize, I'm not here to do this with you if we didn't do it last class, but we had the cool arrows or the sinking arrows are cool, so we colored those blue and they're sinking. When the material hits the lower mantle, which is a solid, it has nowhere else to go, so it gets pushed to each side until it gets heated again and then it rises. And then similarly, it hits the crust, which is a solid. It can't go anywhere. So it gets pushed to each side as well until it cools down enough and starts to sink. It doesn't cool immediately. So that's why it kind of takes some time to create this cycle. And so you can see there's a cycle here. There's a cycle here going the opposite direction. And so what we did in class is we talked about how the crust is broken into multiple different pieces. And so we just drew these lines right here to break up the pieces of crust. And then I asked students, what direction will the plates move? Thinking about, is it going to go left or right? And hopefully you're able to come to the conclusion that this one will go right, this one will go left, this one will go right, this one will go left. So the crust is going to move whatever direction the mantle under it is moving because it is like a raft floating on a river. Whatever direction the river underneath it is flowing, the crust is going to flow too. And so based on this information, it shows us how plates can move apart, they can move together, and that should help you understand which student had the correct response for explaining why the crust moves. Reach out if you have questions.